The Chain Rule by Keanu Romero.
And Chance Little Boy. In the late 17th century, Gottfried Leibniz and Isaac Newton both discovered the concepts of calculus separately, using different notations. The first known use of the chain rule was by Gottfried.
The only use for the chain rule is to differentiate complex expressions. That's it.
The definition of the chain rule is the derivative of the outside argument being done on the inside argument times the derivative of the inside argument, depending on how many arguments you have in the equation.
So example 1 is pretty easy.
First, so our function is cosine 3x. And the derivative of cosine is negative sine, so we bring that down, and then we keep the inside argument the same. And since the derivative of the inside argument is 3x, we bring that out and multiply. After simplifying, you get negative 3 sine 3x.
Example number 2, not as easy.
Although this example is still pretty easy, we're only adding so much. Our function is sine of 4x cubed. The derivative of this, since the derivative of sine is cosine, we bring that down and multiply that by 4x cubed. The derivative of 4x cubed is 12x squared. So after simplifying, we get 12x squared cosine 4x cubed.
So the third example is not so easy. It's actually pretty hard. So first we have 4 layers here, and the first layer would be natural log. Second layer would be the fifth for cosine to the fifth, and the third layer would be cosine, and the fourth would be 3x to the fourth. So the derivative of we can cut this out. So the derivative of natural log of cosine to the fifth times 3x to the fourth equals the natural log over cosine to the fifth times 3x to the fourth, while keeping the inside the same. Okay, let me repeat that. First, we find the derivative of the first layer since it is the very outside layer, and the natural log is 1 over x. So we would put 1 over the inside function, so cosine of to the fifth times 3x to the fourth times cosine times 3x to the fourth to the fifth, since cosine to the fifth times 3x to the fourth is the same thing as cosine times 3x to the fourth to the fifth. Then we do power rule, since the 5 would be the second layer. Then we would do power rule and move the 5 to the outside to make it 5 cosine times 3x to the fourth power, since the 5 would be the second layer. Then we would simplify to have 5 cosine to the fourth times 3x to the fourth over cosine to the fifth times 3x to the fourth, while timesing negative sine times 3x to the fourth times 3x to the fourth. And we have negative sine because we found the derivative of cosine. Then we would simplify again to have 5 over cosine to the 3x because the cosine of 3x times 3x to the fourth cancel out. Then we would keep negative sine times 3x to the fourth and find the derivative of 3x to the fourth, which would be 12x to the third. Now we can simplify all together in 2 parts. In the first part, we would have negative 60 times x to the third, because 12x to the third times 5. Then, I'm saying it again. now we can simplify all together in 2 parts. The first part, we would have negative 60 times x to the third because of the 12x cubed on the outside times 5. Then we would have sine times 3x to the fourth over cosine 3x to the fourth because of natural log. And the second part of the simplification, which would be the final answer, which would be that negative 60 times x to the cubed, because you move the negative. Okay, let me say it again. And the second part of the simplification would be the final answer. And the final answer would be negative 60 to x third, because you would have the negative of sine move to the outside, and tangent of 3x to the fourth, because sine times 3x to the fourth over cosine of 3x to the fourth equals to tangent times 3x to the fourth.
Some real life examples would be when we had the lady come into our class who was a mathematician who worked at NASA and used derivatives to find the displacement, velocity, and other things on the Mars rover as it approached the surface of Mars. We picked this topic earlier in the year because we had not yet studied it.
Say it again. Fuck.
We picked this topic because earlier in the year we had not studied it yet. By doing the research and making this video, we have further expanded our knowledge on the usage of the chain rule and how we can use it further in the future. Thanks.